Hello, and welcome to the Rolls Battery Engineering webinar series. Today, we're going to talk about the Rolls Battery Troubleshooting Form. But first, we're going to talk about a few other things just to get them out of the way. Some housekeeping items. We try to keep the presentations down to about 30 to 40 minutes at most with Q&A sessions. This one will actually be closer to about 20 or 30 minutes, so it won't be very long. I've muted everybody's microphone so we don't get echo. If you have any questions, there's a text field on the right-hand side of the screen. Type in your questions there. We'll keep an eye on that and answer the questions verbally. Read the question and answer the question verbally. If you don't have access to the chat pane, you can email your questions directly to me at steve@surret.com and we'll respond directly. And for those of you who are watching this on YouTube, because this is going to be posted on YouTube, comments, suggestions, we encourage those, both positive and negative. The negative ones at least allow us to try to fix the issues with the presentation that you didn't like. Those comments and suggestions would be greatly appreciated. My contact information, or my name is Steve Higgins. I'm the Technical Services Manager at Rolls. My email address is steve@surret.com, and here are my phone numbers. So the reason why we're here today and the reason why we're watching this is the warranty claim and troubleshooting form. We have put this form together because it's difficult to troubleshoot these systems, and without, what I like to refer to as playing 20 questions, it's an easy way to collect data on a system, getting as much data from a single source as quickly and as simply as possible. That way we can make it a warranty or non-warranty determination fairly quickly. And so this form answers most of those questions up front. There's a few others that I'll get into a little later, but I'll get specifically into the form a little bit later in the presentation. The general purpose of this form, first and foremost, is to collect the system data. This allows us to proactively troubleshoot the system and recommend adjustments to avoid potential system failures, either right now or even in the future. I look at 15 to 20 of these a week. This allows me to go to the customer and say, yeah, your specific gravities are a little low, bump up your charging voltages. This allows us to evaluate that system and let the customer know what's going on. It speeds up the troubleshooting process. Usually what happens is we get an email from somebody, either a do-it-yourselfer or installer. Yeah, I bought these S550 batteries 6 months ago, and specific gravities are all low. Well, that doesn't really tell us anything. We appreciate it, but that really doesn't give us any information. A lot of customers, I had a phone conversation today. The customer said their Series 4000 batteries, they have a blue top and a red case. Well, that describes about 4 or 5 different models of batteries. So that allows us to speed up the troubleshooting process. This form allows us to speed up the troubleshooting process. It allows us to document manufacturing problems so quality control can fix them. That's important. If we start to see documented multiple of the same failures over and over and over again, that allows us to go to a specific date code and go, okay, we need to start pulling some of these date codes back, or we need to be a little more proactive at fixing these issues. Warranty tracking. Again, we need to, Rolls Battery Engineering is a for-profit business. It's run by a family. We are, everybody's trying to feed their families and their children. But we do need to keep track of what we are spending on warranty. There are companies, all over the world who the bean counters tend to try to get rid of the warranty process, when I personally think that the warranty side is probably it's the best advertisement that you can do for a system, because if you can, take care of a customer, on true warranty issues or even the borderline warranty issues, most of the time customers will come back. It's easier to keep a customer than try to find new ones. And then, of course, collecting the data. This form allows us to go to companies, other inverter charger companies, and make suggestions to the way they're charging batteries based on the data that we collect. So it allows us to help improve product design, both on our part and on our on basically our partners' parts, the inverter companies and the solar charge controller companies that we have to work together with to make sure everything works. When is this form required? For any warranty claim. Warranties have to be documented. When a warranty claim comes in and the customer emails us and says, I've got a set of S550 batteries that I bought 6 months ago and they don't work. Well, unfortunately, that doesn't fly with my quality control folks. It doesn't fly with my boss. So we need to have some sort of documentation on the system to see what's going on with the system for me to be able to get that covered under warranty. Troubleshooting can take a couple weeks. You know, I've got a couple systems I've been working on for about 6 months, troubleshooting. So the first thing what you're going to do is basically what you're doing is you're taking a snapshot. You fill out the first page that has your information, has system information, charging information, and then we're either going to, you know, outright approve a warranty, or we're going to start the troubleshooting process. We might make some changes, some settings, go 1 to 2 weeks later, take a look at it again, see what's going on. So this allows us to take snapshots of what's going on with the system so we have everything documented. Even when troubleshooting, even if you've got a 10-year-old battery bank and it's not covered under warranty, or the issue's not covered under warranty, you know, this helps troubleshooting. This helps me when I'm troubleshooting with you, because again, I look at 10 to 15 of these forms a day. That means I look at 75 forms a week at a minimum. That's 60 to 70 different systems every single week that I look at. If you call me up today, which is September 6th, and then you call me up again on October 6th, I've already looked at 200, 300 other systems than yours in the last few weeks. So it helps me document that so I can go back and look at it and go, okay, you know, this is that system. Here's what we can do. Try to maintain some sort of fluidity in the information that we try to give out. Now what I'm going to do is I'm going to go to the form itself, bring it up, and I've already kind of filled this one out. Basically what you want to do is you go to our website, www.rollsbattery.com, or you can just type in rollsbattery.com. Let's see here. Here we go. So we bring up our web page here. We're going to go to rollsbattery.com or surrett.com, either way. There's 2 ways to get to it. I'm going to open up each way and go to it in Windows. First way to get to it is the technical resources side. You click on the technical resources tab. That is this tab right here, the resources. If you get to that, sorry, my spotlight's not working. So I highlighted here my resources tab. Once I click on that tab, it will bring up a technical resources page. Next thing I'm going to do is I'm going to click on the technical resources link here. And what that will do is that will bring up a list of technical resources. This is where we have, you know, our battery, or what our warranty is, the warranty claim and test sheet. The warranty claim and test sheets here. This is how our warranty is described. A maintenance logbook that you can print out and give to the customer. You can print it out multiple times and be able to use as a logbook. Any of the SDS, in the SDS sheets, those are now called SDS sheets. They used to be called MSDS sheets, but they've changed them in the last few years. Certifications, any certifications, ISO certifications, certificate of conformance, AGM, CE certifications. You know, just some basic information of the system, of the batteries. So what you do is you just click on this to open up the form, and that'll bring open the form here. At this point, what I like to do is, I'm not a big fan of working on it here because a lot of people have issues saving it. What you want to do is you want to click in the upper right and click Save As. You know, the download form, and you save it as. So you save it as something on your computer hard drive, and then you fill it out. That way you're working on a live form. What I've done here is I've filled out the form, and I've got Steve test form PDF, and that's what I've named it as. You can name it as, typically the best thing to do is your first name, your last name, maybe your phone number, .pdf. And that way we've, if something goes haywire with the form, I at least have your phone number to call you back and say, listen, something was blank, whatever's going on. On the form itself, we're going to mark it up with the pen here. Customer information. So I've gone ahead and just filled out information. Basically name of the customer. So if you're an installer, we want the customer name. If you're a do-it-yourselfer or you're the owner of the system, put your information there. So we have your contact information, your name, your address. If it is a prorated warranty, that's the address that we're going to send the prorated reimbursement check to you. The current date, contact information. If you submit this in writing, in handwriting, please make sure it's legible, especially if you fax it in. A lot of times the faxes or even pictures can be difficult to read. If you want, you can put your installer information down below. That gives us an information person to contact, or if you are the installer, that way we know, you're the installer, you installed it for John Doe, Ace Solar installed this for Steve Higgins. They're contacting me, so I'm going to contact the dealer or the distributor prior to contacting the end user, unless the dealer or distributor specifically wants me to work with the end user directly. That way we keep things as clean as possible. I'm going to scroll down here, bring up the next section. The next section talks about the batteries. We manufacture about anywhere between 300 and 400 different varieties of batteries. There's the Series 4000, the Series 5000, the Series 4500, the tubular gels, the AGMs, the AGMRs, and then there's a whole railroad line that does railroad forklift batteries such as that. And they're all a little bit different. They've all got specific model numbers. I'm going to use the S550 as an example. And so what I have here is the S550 batteries. That's the battery model. Say we installed these batteries on September 15th, 2000. I've got 8 batteries in series, 1 parallel string. Basically, that gives us an idea of what's going on with the system. 20-hour rate, that battery bank capacity is 426 amp hours, and it's the original installation. My system voltage is 48 volts. You can use the other. Reason why we have the other is there's some systems that run all the way up to 1,000 volts DC, so it's nice to know that ahead of time. Battery date codes on all the batteries. If it was prior to a couple years ago, all the Series 4000 batteries had a 4-digit date code, and that would be the code like this 4260. Okay. And basically what that date code would mean is the battery was manufactured on the 4th day of the week, the 26th week of the year, and the 0 is the last day, is the last number of the year. So they would have been manufactured roughly around June of 2000, ballpark, right around June of 2000 on a Thursday. So 2 years ago, we changed our numbering to be more of an actual date code. So it went to an 8-digit code. And on the newer batteries, the S550s, the newer chassis batteries, anything that's newer and about 2 or 3 years old, it has an 8-digit code on the top of the battery instead of the side. So it's a little bit easier to see. You don't have to move the batteries around. Right here is how we discuss and talk about what the battery date codes are for the flooded product and the AGM product. So this allows you to know exactly, when that battery is manufactured. So if you get a battery, you can look at the top of the battery and tell when it was manufactured. There's a backup date on the lower right-hand corner of the label of the battery. So if you look at the label that tells you the model number on the lower right-hand corner, that's the date the battery actually left the plant. The date that's stamped on the terminals or the top of the battery, that's the date the batteries were manufactured. So they were typically the batteries, they spend 1 to 2 weeks at the plant at the most. All right, the next screen. And I'm just going to scroll down here. Application and charge source. Basically, what this does is allows us to figure out what the application is, what we're dealing with for the application in general. So What type of application is it? Renewable energy, marine energy, motive power or industrial, railroad or diesel start. Basically, you just want to check mark that. If it's a renewable energy system, the type is it an off-grid system? Are the batteries the primary source of power, basically? Grid tie system. That means that you're selling power back to the utility, and you're using the batteries in a backup application. Hybrid. Basically, a hybrid system is where you're kind of using a mix between a grid tied and a backup, and then the last but not least is the backup system. Basically, where you're floating the batteries for 22 hours a day, and then you're using the batteries during intermittent power outages. Just the type of system. Load size. What the load size is basically what we're looking for is the average amps AC of load that you have on the system. You can give us just an AC or DC, doesn't matter which, but it gives us an idea. Gives us an idea how much current you're drawing. The next one would be load time. What load time is let's say this is a business. Say it's a business and it's an off-grid business and they're only running 10, 12 hours a day. That's what you put. You're running that load for about 10 to 12 hours a day. If this is an off-grid house, that load's going for approximately, if you give me an average number, that load's going for approximately 24 hours. The next thing is AC charge output. Generally, what this is we're looking for an idea of what your average charge output is. It's a 48 volt system, so obviously 48 volts. Generally how much amperage each one of your charging sources delivers. And then this gives us the PV panels, the wind, or the other. This is your renewable sources. So if you had here you put I've got 12 250 watt solar panels. If you had a wind generator, then you would list your wind generator. So we've got a wind generator that's a nominal 48 volt wind generator that generates roughly about 20 amps of current when the wind's blowing. Just an average, just an idea to give us an idea of what's going on for your consumptions. The next thing is if you have a single phase charger. And what this is you see a lot of this on marine applications or motive power or even railroad applications. Basically, it's an individual standalone charger. Most common one would be like a telecom generator where it runs at a DC voltage, like a telecom system that's going to run at 54, 55 volts. That's what it's going to charge at. That gives us an idea of what you're dealing with there for your generator or your standalone charger. Renewable energy system, a little bit more detailed information about the renewable energy system. Basically, what PV panels do you have? Are they 60 cell modules or 72 cell modules? What's their voltage at maximum power? That's what we're looking for here to give us a better idea of what kind of panels you're using. Wattage, if you have, in this particular case, we have 12 250 watt solar panels. Their voltage is, ISC or VOC. It's roughly around 40 volts. It doesn't have to be. It's not purely scientific. It just gives us an idea. I have had customers with 24 volt systems who are using 60 cell modules wired all in parallel to charge a 24 volt battery bank. That will not work. If you're going to use a 60 cell module at 24 volts, you have to have at least 2 modules in series to get the voltage up high enough to charge the batteries. So, and that's the reason why we ask these questions, is that every once in a while we find systems like this that, you do months and months of troubleshooting, you swap out a few batteries, doesn't fix the problem. The next thing you know, you find out, well, I got these panels, they're 60 cell modules and they're only putting out 27 volts or 26 volts. So you just want to be careful with that. We go AC charge sources. AC charge source is basically a 120, 240 volt generator. If it's a 240 volt or 120 volt generator, and the wattage of the generator. The reason we ask this question is if you couple a 2,000 watt generator with a 3,000 watt inverter, you're not going to maximize your charging capability when you are running your generator. So that helps us, suggest better settings to use while you're charging while you're charging. Last but not least is the charge controller and the inverter charger settings. This is probably the most important, one of the most important things on these forms is your bulk, absorption, float, equalization, voltage, your average amperage that you see. This is not your maximum amperage, but when the charger's in the bulk mode and in charging, when it first starts charging it, ballpark where that current is usually. Most customers, especially do-it-yourselfers, can repeat that, off the top of their head, and because they're very aware of what's going on. So just give us an idea what that is. And then, of course, what you've programmed your absorption timers to, or your timers, basically absorption time or your equalization time. Those are important because most often we find that those are usually too short. And then, of course, that for the charge controller and the inverter is very important. It's important to know both of them because depending on the system, sometimes they're a little bit different. Sometimes you have the charge controller a little bit higher than the inverter to optimize what the charge controller is putting into the batteries. And then in this section here, we're just asking basic information about what charge controllers you're using. You can multiply it if you had 2 FlexMax 80s, you just put times 2, whatever you're putting in there, whatever you're doing there. All right. So what we're going to do is we're going to move down a little bit more. And so what we've done with this form is that we have, first of all, we have a specific gravity chart. We put this on here because we get the questions a lot. 1255, 100% stated charge, 1255 to 1275. Now, in a solar system, 1265 to 1275 is really where you want to be, especially for a system that's cycling. If you have an industrial-based system where you're getting 8 to 10, 12 hours of charge a day, then a lower specific gravity is okay. But in a solar system, you're only charging 4 to 6 hours a day on average. And sometimes that's even worse. So one of the things you want to watch out for is you want to get your specific gravities a little bit higher because you're not charging as long as you normally as an industrial application would charge. We have a checklist. Make sure you clean and torque your terminal connections. Use a torque wrench. Get a torque wrench. They're not that expensive. They're well worth the investment. If you don't have a torque wrench, that's one of what I call the Goldilocks rules that apply to batteries. There's too tight, too loose, just right. When you start noticing that the washer is biting into the terminal, you're probably too tight. If you notice that the terminal temperature is hotter than the rest of the terminals, then it's probably too loose. So it's a good idea to have an IR temp sensor. You can get them for 25 bucks at Lowe's or Home Depot or a hardware store. That way you can check that out, check those out. Electrolyte, inspect, top up as needed, especially flooded models. If you've got a flooded battery, you go and you do your spot check your specific gravities. You notice a half dozen or a dozen of the cells are a little bit low and electrolyte. You take some distilled water and you put some distilled water in those batteries, top them up, do a full recharge, and then spot check your cells again afterwards. That's a good thing to do. Make sure your battery temperature is attached. A lot of inverter companies, charge controller companies will sell you a temp sensor that has a double-sided sticky tape on it, and you come back to it 6 months afterwards because it's sitting in a hot room and the temp sensor is sitting on the floor. It's not doing your batteries any good there. You want the temperature of the batteries, not the temperature of the air. And the reason for that is that the inverters and the charge controllers will regulate the charge going into the batteries based on that temperature. And if the temperature sensor is not connected, it's not adjusting the charge voltage. And so you could be overcharging or undercharging your batteries while that temp sensor is not connected. It's very important that that temp sensor is connected and that you have one. Okay, so moving on. Ambient temperature, this just gives us an idea of the room that it's in. I've got it expressed here in Fahrenheit. You can express it in C, Fahrenheit. We'll figure out the calculations. That's no big deal. So the next thing that we do here is I'm going to change this up a little bit and zoom out. All right. So now what I've got here is I've got a whole list of 24 cells. And so these are 6-volt batteries. There's not really an easy way to measure. There is a way to do it. I'm not going to get into it now, but there's not really an easy way to measure a 6-volt battery, to measure a 3-cell 6-volt monoblock battery, to measure each individual cell. It's not 100% necessary. So basically what we're looking for is we're looking for a battery voltage measurement. We're looking for a specific gravity and a battery voltage measurement. And so, for example, from positive to negative, typically, if this is the positive side, what we have people do is we have them circle the positive side, and then so that we know, this is the positive, this is the center, this is the negative. Positive, center, negative, positive, center, negative. So we know specifically what cell is causing. This helps especially with 2-volt cells if we're going to replace a full 2-volt cell, so that we send the correct cell to you. Specific gravity, you can express this in 1.200, you can express it in 0.200, you can express it in 1200. Generally that gives us an idea of where it's at, and what's going on. Battery temperature, it's a good idea to have that infrared thermometer to go through and measure the battery temperatures of the cells. A lot of times, if you were measuring 95, 95, 96, 94, 95, 102 or 110, that cell's getting a lot harder than the rest of the cells in the battery bank. That's an early indicator of something going on with that cell. That could be a warranty issue. It could be a non-warranty issue. It could be the overall batteries in the process of failing. So something to definitely look at. And then, of course, we've got our individual battery voltage readings. And so this is battery voltage readings with no load. And so you want to measure, it's called an open cell voltage. You'll want to measure that with no load individual or in the beginning, and then kick on some load. Give us an idea how much current you're running. If you're running 2,000 watts in a 48-volt bank, you take 2,000 watts, divide it by 48 volts, that's 41 amps of current. Put 41 amps of current there. You don't have to run it all the way down. You can just draw a line, 41 across the way. And then you write down what the voltages are loaded. You could do this over time. You could do it one time. But a lot of times what you'll see with a battery bank that's got you say you've got a good specific gravity, but the battery's in the process of failing, you'll see, something like, 5.8, 5.8, 4.2, 5.8, 5.8. So you'll see differences in those cell voltages. An early indicator. This is where maintenance comes into play. And so if you have one string of batteries, you'd put it here. If you had 2 string of batteries, you'd put the second string into these columns, and that would give us a snapshot of the battery bank at a particular time. Especially helps us troubleshooting. Like, for example, this battery we're looking at, they're all 1200, 1220s. There's one in the 1300. They're all just a little low. One's a little higher than I would expect. That might be a misreading. Could be a lot of things. There's one that's a little low. This could be, see here, this battery here could be in the process of failing. Cell 789. This battery, I would probably put a watch on this battery and go, hey, let's put a watch on that. Let's make some adjustments to our charge settings, and let's put a watch on that battery. Call me back in a couple of weeks or in a month, and let's see what that battery's doing with a little bit different charge settings. That's all part of the troubleshooting process. And then, of course, down here, I'm going to scroll down a little bit more. Then, of course, right here, any irregular occurrences, this is where you put in writing, let's see here, cell 7, 8, 9, using up more water, etc., etc. So this allows a written communication, and so allows us to take a look at allows me to try to be there with you. Unfortunately, if if I'm in Western Washington, or if I'm on a business trip out in Africa or Latin America, it allows me to look at this and almost be there with you. So when you're done with this, basically you go up to File, hit Save As. You save that form again as a different name, and then you can email that form to us. So now that I've gotten into that, let's see here. What do you do? What do you do when you've completed the form? What to do when the form is completed? Couple things. You can email the form to support@rollsbattery.com. Okay. What that will do is that will start, and you will get an automated reply from our ticketing system with a ticket number, and it'll say that we'll take a look at your information. Typically, depending on the time, I usually get to these. Jeff Miles and I typically get to these, within 24 to 48 business hours at the worst. Most of the time, I see them. The only time that it becomes an issue is if I am traveling, or Jeff and I are traveling. Sometimes there can be a little bit of delay, but worst case scenario, typically 24 to 48 business hours before we will get back to you. We try to get back to you as soon as possible. The more information you can provide, the easier and faster the process is. Okay. If you already have logs of your specific gravities, take pictures of those and send them in to us. A lot of folks have Excel spreadsheets. I have an Excel spreadsheet that I can send out, or if you want to request it, it's available on my Google Drive. Send me an email, say, Steve, I'd like access to your Google Drive. I'll invite you to that, and you can have that Excel spreadsheet. Sometimes pictures of the systems help too. It's nice to be able to look at the systems. Sometimes people will try to hook up a 12-volt system using 1-aught battery cable. In most cases, 1-aught battery cable for a 12-volt system is way too small. You can fill it out by hand, you can scan it, or you can fax it, or if you have a smartphone, you can take a picture of it and email the pictures, the page 1 picture and the page 2 picture. That seems to be pretty easy for a lot of folks. You can do that. And again, you can go old school and you can fax it. You can fax it to 902-597-8447. And just make sure you put on it attention warranty claims. That way it gets routed to the proper place, or you can put it attention Steve Higgins or technical services manager. And what will happen is it'll get routed to the proper place. We don't do this form to make things difficult for you. We do this form to try to smoothen out the troubleshooting process. If we aren't able to do this troubleshooting, or the customer is unwilling to do this troubleshooting, the battery, we really have a hard time being able to provide warranty service on it, because there really is no verification of what's going on. In those cases, the batteries need to be either shipped back to the plant or taken to an authorized distributor for testing. In that case, the distributor, either the distributor will do testing for us, or the distributor will ship the batteries back to us to get them taken a look at. Those shipping costs are on the customer. The Rolls will not pay for those shipping costs. If it's a warranty, we'll pay to ship them back to the distributor, but the shipping costs are on the customer. So this is a way to get the troubleshooting done quickly, easily, with minimal cost, to try to make sure we solve the problem as soon as possible. Okay, so anyways, my name is, again, here's my contact information. If you want some access to that information on Google Drive, go ahead and send me the email at steve@surratt.com. The other thing that you can do, anyways, the other thing that we'll do is that will get you invites to these webinars when I do live webinars. Thank you very much for listening. I appreciate it, and have a good day.